Welcome, welcome, welcome. Let's do some algebra today, shall we? So we're going to start our algebra journey with a basic area of one-step equations. So we're going to learn how to solve simple equations to find the values of unknown variables. I'll let you enjoy this joke for a minute. Okay, go ahead and pause, add this to your table of contents, copy down the objectives. So today we're going to focus on one-step equations. So when we talk about solving an equation, we're talking about finding the values of the variable, the x, the y, the whatever, that make the equation true. And we call those things the solution to the equation. So if we say x equals 5, then x would be the solution to the equation. I'm going to demonstrate a couple with some algebra tiles. You can enjoy that joke too. Don't try it on a test though, won't work for you, haha. Alright, so before we begin, remember that equations are like scales. They're equal, meaning they have the same value on both sides, even if they look different. They have to stay balanced that way, so if we do something to one side, we got to do the exact same thing on the other side, otherwise it won't be equal anymore. So I'll start with something really basic. Okay. Alright, so if I go 2 plus 3 equals, equals 5. I'm just going to use my finger, that's faster. Alright, we can all agree that's true, right? We have 2 tiles over here, we got 3 right here, and then if we put them together, we get a grand total of 5. So what happens if I add 2 to both sides? Alright, well, on this side I have 7. On this side I also have 7. So that's fine. What if I take, oh, well, the 3 stuck together. So let's say, what if I take 3 away from both sides? Alright, well, now I got 4 over here and I got 4 over here. So everything's cool. What if I add 1 to this side and I add 2 to this side? Well, now I have 5 over here and I have 6 over here. So they're not equal. So again, we see if we want to keep them equal, we have to do the same thing to both sides. All right, now let's do some algebra. I'm warning you right now, the problems you're going to see me do, especially at the start, are going to be really, really, really easy, and of course you can do them in your head. We will get to some big, honkin', nasty 8th grade level problems fairly quickly, and if you don't get down the basic skills I'm trying to show you and show your work the way I'm trying to show you, you're going to really struggle with those. So I know you can solve this problem in your head. Good for you. Just trust me that I know what I'm doing here and follow these steps and you will be ready for the big scary problems. Okay? All right. So if I'm trying to solve my x right here plus my 4 right here equals 6, I'm trying to figure out what does x equal. Well, like I said, hopefully you can do that in your head and you can go, okay, what plus 4 equals 6? Okay. But really, if I want to solve it with tiles, I need to get x by itself. Well, what is hanging out with x? There are 4 ones over here hanging out with x. So how do I get rid of them? Let's just slide them on out of there. If I do that on one side, what do I need to do on the other to keep it balanced? Well, I need to take 4 away over here as well. And then I see my solution of x equals 2. The way I show that numerically is to get rid of this plus 4 right here, I'm going to minus 4. And when I minus 4 on both sides, these cancel out. That gives me x by itself over here. And 6 minus 4 right here is 2. And I see x equals 2. Alright, another example. So, x plus negative 4 equals negative 5. Alright, again, I'm trying to get x by itself. So what's over here with x? These 4 reds are over here with x. How can I get rid of them? Get them on out of there. So if I get those out of there, what can I do over here? I can take 4 away over here. And now I've done the same thing to both sides, so I know it's still balanced, so I can see that x equals negative 1. Alright? Sometimes you'll see it where it's reversed. So the x is not always going to be on the left, and it won't always be x either. Alright, so now we're getting to the point where like, hey, this is getting a little weirder. I might not be able to solve this in my head. Maybe you can, maybe you can't. So I've just modeled 3 equals -7 plus x right there. And again, my goal is not to get this stuff by itself over here. My goal is to get x by itself. So what do I have with x? I have 6 reds. Well, I can't just take them away anymore because I don't have 6 reds on the other side. So if you think way back to when we did integers, how did we get rid of those? We created 0 pairs. So if I add 7 yellows on this side, that's going to cancel all this business out. Oh, get out of here. Thank you. All right, and since I added 7 yellows over there, 3, 4, 5, 6, 7, I have to add 7 yellows over there, and then what am I left with? I have x on this side, and I have 10 on this side. So I can see that x equals 10. Okay, the way I would do that paper and pencil is I added 7 to both sides. That got rid of the -7, and that left me with x equaling a grand total, of 10 for me. Okay, what about, like, not just adding and subtracting, what about when we have multiple x's? Well, if I have 3x equals 12, all right, well, I sped that up for you. So again, I'm still trying to get x by itself. I can't just take away 2 of these x's because I don't have x's on the other side to take away. So instead, if 3x is equals 12, then I want to know, hey, what does 1x equal? And so then I can just kind of like, since I divided it into 3 piles on one side, I'm going to divide it into 3 piles on the other side, and I can see that, boom, x equals 4. So I made 3 piles, I divided by 3 on both sides, and that showed me that x equals 4. Okay, I'm going to fast forward a little bit. What about when we divide x? So if I have x divided by 2 equals 3, well, that shows me x equals 3. I want half of an x. So I'm going to just cut my x in half and pretend like half of it doesn't exist. So I have x divided by 2, or half of an x, equals 3. So what if I want to find out what x is all by itself? Well, let's make it a whole x again. I made it twice as big on that side, so I'm going to make it twice as big on the other side. So I got rid of that dividing by 2 by multiplying by 2. And whatever I did on one side, I'm going to do on the other to keep it balanced. And now I see that x equals 6. All right, let's jump into some notes here. Go ahead and pause, copy this down. So we're still going to box and circle like we've been doing. Our whole goal is to get the variable, the x, the y, the whatever, alone by using the inverse operations. Inverse operations is a fancy way of saying doing the opposite. And we want to make sure we're doing the same thing on both sides of the equation to keep it balanced. The last thing we're going to do is you should never get an algebra problem wrong because you can check your answer. You can throw your answer in for x and see if it works. Okay, so I'm going to box and circle. Okay, and now I'm going to get x by itself using inverse operations. So here's x. What's with x? A -6 is with x. How do I get rid of a -6? I'm going to add a +6. And whatever I do on one side, I'm going to do on the other. All right, now I'm going to treat this like a big old, equation thing. So these guys cancel out. So what I have left over here, I have x. What do I have over here? I have 10 plus 6, which is 16. And I get a final answer of x equals 16. My last step to check is I'm going to take this x, and instead of x, I'm going to write 16. So -6 plus 16 equals 16. All right, well, I got different signs, so I subtract. Oh, sorry, not equals 16, equals 10. Whoop. I was like, wait a minute, that doesn't work. And then when I do that, I actually see that's 10, and 10 equals 10, so I know I got it right. Let's try this one over here. I'm going to box and circle. I'm going to try to get x by itself. So what's with x? A -10. How do I get rid of a -10? +10. That's my inverse operation. And whatever I do on one side of the equation, I'm going to do on the other. So I'm going to draw this line right here to kind of show like, hey, I'm going to total this business up. I got x by itself over here. I got that canceling it out. I'm I'm going to put my equal sign back, and 13 plus 10 is 23. And then I can do my check by plugging in that answer of 23 instead of x. And when I see, okay, different signs, I subtract them, I'm going to get 13. Hey, lo and behold, 13 equals 13. I did it correctly. All right, let's move it to the notebook. So go ahead and press pause, copy this down. It is so nice, we're going to write it twice, so that way we can ugly this one up. And again, I know you can probably do this in your head, but just humor me, realize it'll get a lot harder. All right, let's box and circle. That'll help us make sure we're just keeping our constants with our constants and our x's with our x's. We're going to use inverse operations to get x by itself. So what's with x? Positive 5. How do I get rid of a positive 5? A negative 5. Whatever I do on one side, do it to the other. Okay, let's total it up. We got an x all alone over here. That was our goal. And then we have different signs, subtract, negative ones over here. So I'm going to get negative 2. And that is my final answer. I'm going to do my check because I'm a smart human being that wants to be sure that I'm right. I got different signs here. I subtract positive ones, and I see that 3 does equal 3. Check. Doesn't take long. All right, let's do one more before I end this thing here. All right, so nice. We're going to write it twice. So go ahead and pause. Write it twice so we can ugly this one up. All right, I'm going to try to get a by itself. So I'm going to box my variables, circle my ones. This will be more important when we get to the more difficult equations, but do it anyways. I'm going to use inverse operations to get a by itself. So I'm going to get rid of this plus 4 with a minus 4. I'm going to draw my little total line here. So a is by itself there. These guys cancel each other out and equal nothing. And then I have negative plus negative, you add, same sign. So I get negative 7 is my answer. Boop. And I'm going to do my check. Negative 7 plus 4 equals negative 3. All right, and then I check in and see, like, hey, did that work out? If these are different signs, I subtract, and I get negative 3 on both sides. So since negative 3 equals negative 3, boom. All right, grab a piece of scratch paper, try these two basic ones. Again, I don't care if you can do them in your head. Can you do them by showing me inverse operations? All right, that's it, guys. Sorry it went a little long, but anyways, try those two problems out. Try it doing inverse operations. Come into class tomorrow with your notes all complete and any questions that you have for me. I do award participation points for asking questions, so don't be afraid. All right, get a good night's sleep, and I'll see you tomorrow.